What identity involving the dot product and the product of the magnitudes does this equation look similar to? So it looks similar to dot product is equal to product of magnitudes. So product of the magnitudes times cosine theta. Now, how do we get this equation to look more like this? What should we do with the product of the magnitudes? Divide both sides of the equation by it. Okay. And when is cosine theta equal to plus or minus 1? How many degrees does theta need to be? So theta is going to be either 0 or 180 degrees. These are the only times when cosine theta is equal to plus or minus 1. Because when it's 0 degrees, what's cosine of theta going to be? It's going to be equal to 1. And when it's 180 degrees, what's cosine of theta? -1. Okay, now let's go back to the problem. Prove that if u and v are parallel vectors, dot product divided by product of magnitudes is equal to plus or minus 1. What does the word if mean? The one with two f's. It's a biconditional statement. So what that means is we need to show that if u and v are parallel, this equation is true. But also we need to show that if this equation is true, u and v are parallel. So this is what it looks like. So u parallel with v. So this is the biconditional arrow. And it's going to be, we're just going to copy the equation. Okay, so when they're parallel, what does that look like geometrically? So if they're parallel, they need to be on the same what? The same line. And they can either be in the same direction, pointing in the same direction, or what direction? Opposite directions. If they're in the same direction, what's theta going to be? Zero degrees. If they're pointing in opposite directions, how many degrees do I need to rotate u counterclockwise by? 180 degrees. Okay, so if u is parallel to v, then theta is either 0 degrees or 180 degrees. So that means cosine theta is equal to what? It's either 1 or -1. In other words, it's equal to plus or minus 1. Okay. So basically we just showed, and I'll write out a formal proof in a second, but we just showed that u being parallel to v implies that cosine theta is equal to plus or minus 1. Okay. And if cosine theta is plus or minus 1, well, then what did we just prove? So if cosine theta is equal to plus or minus 1, we can just change cosine theta to this. And we just showed, okay, I'll write it here. We just showed that u being parallel to v implies, so we only went one way. If this is true, then this is true. We just showed that u being parallel to v implies that the dot product divided by the product of the magnitudes is equal to plus or minus 1. Now we also need to show that the reverse is true. So basically, let me get another sheet. So basically, we need to show that the dot product divided by the product of the magnitudes being equal to plus or minus 1 implies that u is parallel to v. So how do we do that? Well, the good news is our steps here are reversible. So basically, if this is equal to plus or minus 1, then we can just do our steps, we can just copy our steps in reverse order. So this implies that cosine theta, right, because, okay, let's write it here. Okay. Yeah, so from the identity here, yeah, let's go ahead and copy that. Okay. Okay. So when this is equal to plus or minus 1, then that means theta has to be equal to, well, when the cosine theta is equal to plus or minus 1, theta has to be how much? Theta has to be 0 degrees or 180 degrees. Okay, and if theta is 0 degrees, then what happens? Then they point in the same direction. And if it's 180 degrees, what happens? They're in opposite directions. So that means they're parallel, which is this. But okay, let's formalize this, because that was kind of just us exploring what happens. Oh, okay. Let's just write it like this. So we'll write from so from this identity, what did we figure out? What did we do first? We got cosine theta by itself. Why? Well, we divided both sides of this equation by the product of the magnitudes to get the left-hand side to look like this. Okay, so to show, what do we have to show first? Just a sec. Okay, so it implies the equation. We looked at it geometrically. have a direction angle of either 0 degrees or how many degrees? 180 degrees. Okay. If theta equals 0 degrees or 180 degrees, then cosine theta equals plus or minus 1. So dot product over okay, what's next? What else did we have to show? Okay, and we also had to show that the reverse is true. So I'm going to just say this. Since our steps are reversible, okay, but that only works, you have to double check that your steps are indeed reversible, because it's not always the case when proving something. But yeah, this is why if u and v are parallel vectors, then the dot product divided by the product of the magnitudes is equal to plus or minus 1.